Look up at the night sky. Instead of the familiar dark void punctuated by distant points of light, a brilliant violet haze slowly creeps across the horizon. The stars are not burning out, they are drawing closer, shining with an unnatural, intense blue glow. What if our universe were collapsing? In our actual reality, the universe has been expanding for nearly 14 billion years. Galaxies drift farther apart, carried by the stretching fabric of space-time. This cosmic expansion, driven by a mysterious force called dark energy, continuously cools the universe and keeps the night sky dark.
Now, imagine a pivotal moment when this expansion ceases. If dark energy were to decay or reverse its behavior, gravity would reclaim dominance over the cosmos. The outward push would halt, and the entire fabric of space-time would begin a slow, irreversible retreat inward. In this contracting universe, the light from distant galaxies behaves differently. Instead of stretching into longer, redder wavelengths, incoming light waves are compressed. This creates a cosmic blue shift, meaning every distant star and galaxy shifts toward the higher frequency, energetic blue and violet end of the spectrum. On Earth, early astronomers would observe a baffling phenomenon. Rather than moving away, distant cosmic structures would appear to be rushing towards us. The Andromeda Galaxy, already on a collision course with our Milky Way, would accelerate its approach, visible to the naked eye much sooner. Because gravity is an attractive force that grows stronger with proximity, the contraction would not remain steady. The collapse would start imperceptibly slow, but would inevitably accelerate over billions of years. Cosmic voids would shrink, and the vast gaps between galaxy clusters would rapidly close.
Our local galactic group would merge into one massive stellar system. As galaxies compress together, gravitational interactions would trigger a chaotic dance of stars. While individual stellar collisions remain rare due to the vastness of space, the overall density of our stellar neighborhood would increase dramatically.
The night sky would undergo a stunning transformation. The darkness we take for granted would begin to fade, replaced by a continuous, diffuse glow. Countless nearby stars and approaching galaxies would light up the heavens, rendering midnight as bright as a perpetual twilight on Earth. This constant illumination would have profound ecological consequences. Diurnal cycles on Earth would disrupt, severely impacting animal migration, plant photosynthesis, and human circadian rhythms. Ecosystems would be forced to adapt to a world where true darkness no longer exists, forever altering the evolutionary path of life. Take a moment to imagine standing under this luminous, violet-tinted canopy. The calm, cool blackness of the ancient night is gone, replaced by an energetic, living sky. It is a beautiful, yet ominous reminder that the universe is actively drawing every piece of matter closer together. Meanwhile, the cosmic microwave background, which is the ancient relic radiation from the Big Bang, would begin to shift. Currently cooled to a frigid 3 Kelvin, this radiation would compress as space shrinks. Over eons, it would warm up, transitioning from microwaves back into visible light. As the contraction escalates, the macrostructures of the universe would experience drastic changes. Entire superclusters of galaxies, once separated by hundreds of millions of light-years, would merge. The immense gravitational pull at the center of these converging masses would accelerate the collapse to extreme velocities.
This compression would force interstellar gas clouds to collide at unprecedented rates. Huge pockets of hydrogen would condense rapidly under the immense pressure, triggering an intense, universe-wide baby boom of new stars. Galaxies would glow with the fierce light of millions of newly ignited stellar nurseries. However, this stellar boom would have a destructive side. Many of these newborn stars would be massive and short-lived, quickly exhausting their fuel. Frequent, violent supernova explosions would occur across the crowded galaxies, releasing devastating amounts of radiation that would strip the atmospheres of nearby planets. Inside solar systems, planetary orbits would face severe disruptions. As stars crowded closer together, their combined gravitational pulls would destabilize the delicate paths of planets. Earth could be nudged out of its habitable zone, either flung into the freezing depths of space or dragged toward the sun. In the final stages of contraction, the ambient temperature of empty space would rise dramatically. No longer a freezing void, the universe would become a cosmic oven. The blue-shifted light and intensifying background radiation would heat the surface of every remaining planet, vaporizing oceans and melting rock. Eventually, even stars would struggle to survive. The heat of the surrounding space would surpass the internal temperatures of stars, preventing them from shedding their energy. Stars would begin to bloat and dissolve into a hot, dense plasma that would fill the rapidly shrinking volume of space. This brings us back to our glowing violet sky. What began as a subtle shift in stellar color would culminate in a fiery finale known as the Big Crunch. In this state, all matter, stars, and galaxies are crushed back into a single, infinitely hot point. Could this ultimate collapse serve as the trigger for another Big Bang, restarting the cosmic cycle of expansion and contraction? As we study our own expanding universe, we are left to wonder if we are merely living in one breath of an endlessly breathing cosmos.